All right, so we have a demonstration here between a Click PLC and a Seymour HMI, or Human Machine Interface screen. I want to show what we've set up here as a basic demonstration. The final result is what you see on the screen right now. We've got a meter, the needle of which goes up and down as Nolan turns the potentiometer clockwise and counterclockwise. So he's got a potentiometer connected to an analog input port on his PLC. It's actually an extra card we added to it, an analog card. And we've configured the PLC to bring that analog voltage data in as a floating point number. Then we've configured the HMI panel to talk to the PLC to interrogate that floating point value and drive a meter display based on it. So we'll show step by step what we had to put in place to make this happen. So first in the PLC, if we look under CPU, we go to System Configuration. It shows us all the cards, the I/O slots in the CPU. And right here on the I/O slot number 1, additional slot number 1 here, that is our analog card. And if I click on Configure, it says this has a range of 0 to 10 volts. But because we're actually powering up with a 9-volt battery with our potentiometer, we set our scaled input range as 0 to 9, and that's going to show up as 0 to 100%, or just 0 to 100, as a floating point number stored in data register DF1. That's kind of the default value, or default location to put floating point values. If we were using the other input ports on that card, we'd have those values going to DF2, DF3, DF4, etc. So what this does, it takes the analog voltage input, digitizes it into a 32-bit floating point number value, and stores that as DF1 inside the PLC's memory. So canceling that, next we go over to the Seymour HMI software. And the first thing you always do with HMI software is configure the tag name database. And in this tag name database, we have a whole bunch of internal tags that came with the HMI, but we had to add our own tag, and we just called it pot to refer to the potentiometer. If I double click on that pot tag, you can see it's going to be interrogating from device 1, which is our PLC name. The tag name we've given it is called pot. It's a floating point 32-bit data type, and it's going to come from PLC address memory DF1. So what the tag name database does is it maps PLC memory addresses to your own chosen tag names. Because DF1 is not terribly descriptive, it's nice to call it something like pot or tank level or furnace temperature or whatever you want to call it, so that when you start putting graphic objects on the screen and linking those to data, you have these nice convenient tag names to use instead of cryptic things like DF1. So we added this tag name to our tag name database. Then we added a analog meter from over here in the tool palette. We just drug that over, and we have this analog meter now. If I double click on that, you can see in this dialog box we told it where to get the data for that meter. It's coming from tag name pot. If we wanted to, we could take a look at any of these other tags we have in our database, but of course pot is the one we want. And we want the display range to be 0 to 100. So when the floating point value in the PLC is a value of 0, that meter should be all the way to the 0 mark. When it's at 100, it should be all the way to the 100 mark. And you can see here, you can change the number of major and minor divisions, you can change the colors of the meter, you can change the style and orientation. You got all these different things you can do. Then what we did is we sent this HMI program to the HMI panel by clicking the send button, and that goes over a USB cable with a B-style connector on the back. Once that HMI program is loaded, we have it talk to the PLC through a serial cable, RS-232, to grab the data and to display. So it's actually running right now. You can see as Nolan turns the potentiometer, you can see the pointer on that analog meter going up and down. So it's a very simple illustration or demonstration of how to show analog data on an HMI panel. So one way to think of the HMI, it's kind of a programmable window into the mind of the PLC. The PLC has its own programming. You can put your own ladder logic, contacts, coils, timers, counters, things like that in the PLC. All the HMI is doing is accessing those memory locations in the PLC to either show you data like this, or you can set up controls on the HMI screen, such as push buttons and selector switches, where you can then send data to the PLC for it to act upon. But right now we're just showing how to read floating point data from the PLC, which in this case represents a potentiometer position.